Hello everyone, welcome to my YouTube channel. So in this section of special problems, this relating to logarithmic differentiation. Alright, so what do we have here? It says we should differentiate e raised to power x. Okay, remember I said you should always attach y here. So the next thing we should do here is take the logarithm of both sides. Okay, so what's going to happen here? We're going to have that ln of y is equal to exponential x, because the whole of this will come to the back, then ln of e. Okay, so at this point we can now take our derivative, and if we do that, we are going to have that derivative of this is 1 all over y dy dx, and this is equal to, this is a product, and so because now meanwhile this one is actually a constant, because we know that ln on itself is equal to the log base e, and so when you have e attached to it, that means log e base e, which is equal to 1. All right, so that means what we have left here is just e. Okay, so in other words, if you take these exponents, you will actually get only e. Sorry, the derivative of x, e raised to power x will still give you e raised to power x. And so at this point, if we multiply both sides by y, this will take away this. Therefore, our dy dx will now be equal to y e raised to power x. And what is our y? Our y is e raised to power x. So you are now multiplying it with e raised to power x, and that's going to give you, by indices, the power here is going to add up. So you have e raised to power x plus x, and that is our solution for problem 1. All right, so let's look at problem 2. Problem 2 says we should also differentiate this, and so what are we going to do? We are going to start with the logarithm of both sides. So here we'll have the log of x raised to the power of ln of 2x squared plus 3, and then remember what will happen next. This power will come down, so we are going to have, okay, and so what do we have here now? A product. This is u, this is v. So if we differentiate what we have, we are going to have 1 all over y dy dx, and that's equal to, now remember that the product through u dv, and so what we are going to have u now, which is ln of 2x squared plus 3, then multiplied by the derivative of v, which is going to give us 1 over x, and that is plus the v, which is ln x, multiplied by the derivative of this. And remember, to take the derivative of this, maybe we can call it h here, and that h is our ln of 2x squared plus 3. Why am I doing this? Because this is a function of function, and so if we call what we have inside u 2x squared plus 3 our u, so it means that our h will now become the ln of u, and if you differentiate this, du with respect to x will be equal to 4x. 3 here will turn to 0, and if you differentiate h now with respect to u, you are going to get 1 over u. So that means your derivative of h with respect to x, which is equal to dh du dot du dx, is going to be equal to 1 all over u multiplied by 4x, and that's going to give us 4x all over u. And what is our u? Recall, this is our u, which is 2x squared plus 3. And so if you bring all of this here, which is now your du, that's the derivative of this whole. Remember, the u here is different from the u here, so the derivative of the whole of this is what we got as this, and that is 4x all over 2x squared plus 3. And so what are we going to have here now? So this is going to give us the ln of 2x squared plus 3 all over x, then plus, now if this one comes inside, you are going to have 4x ln x all over 2x squared plus 3. Okay, so this can actually be a solution, and you can decide to bring the two of them together by taking LCM. Alright, so and that's where we're going to end it for this video. Kindly subscribe to our YouTube channel. Please do like, comment, and share our YouTube videos, and we'll see you in our next video. Bye.